Python is an incredibly readable and intuitive language out of the box. But when you create your own custom objects, like a robot or perhaps a shopping cart, Python doesn't automatically know how to handle them in everyday operations. It needs a little help to understand your intent. This is exactly where magic methods bridge the gap. If we look at this central panel, these are special methods characterized by double underscores on both sides, like str or add. Because of these double underscores, they are commonly referred to as Dunder methods. You've likely already seen the init method to set up an object. But there are dozens of others that act like a magic wand to teach your objects how to behave. By implementing these methods, your custom classes can behave exactly like Python's built-in types. This allows them to respond naturally to standard actions like printing to the screen, basic addition, or finding their length. To really cement why this matters, let's look at the employee analogy down here. Imagine you hired a new employee who simply doesn't speak your language. If you walk up and ask them a basic question, they might just stare at you blankly. They haven't been taught how to respond. However, if you teach them to answer, "What is your name?" they can confidently introduce themselves. In Python, this is exactly what the str method does. Similarly, if you ask, "How many items do you have?" and they tell you, that is the len method stepping in to provide the count. And if you ask, "Are you the same as this other person?" to see if two things match, that is the eq method handling the comparison. Ultimately, magic methods are essentially the social skills you teach your object, allowing it to converse in Python's native language and work harmoniously with the rest of your system. The best part about these social skills is that you almost never have to call them directly. Python will naturally invoke them behind the scenes as you use standard operators.
The most important thing to remember about magic methods is that you almost never call them directly. Instead, Python acts as a hidden translator behind the scenes. When you write standard intuitive Python code, like using the print function, the len function, or even just a simple plus sign, you aren't just running basic operations. You are triggering Python's internal machinery. It steps in and automatically looks for the corresponding magic method defined inside your custom object. It takes your simple commands and translates them directly into these internal Dunder methods. For example, calling len on an object actually tells Python to run silently the __len ___ method. Let's look at the reference table on the right to see this mapping clearly. If you want to print a shopping cart object, Python internally triggers the string method. If you use the len function to count items, it triggers the length magic method. Adding two objects with the plus symbol invokes the add method. This seamless translation continues for equality checks using double equals, less than comparisons, or even checking if an item exists inside something using the in keyword. To really see why this is so valuable, think of building a custom object from scratch like a robot. Before we add any magic methods to our robot class, the object is raw and completely unpolished. Python simply has no idea how to interact with it. If we try to print the robot, Python panics and spits out a messy, unreadable memory address. If we try to use len to count its tools, or if we try to add two robots together, Python crashes and throws a type error. It just doesn't know what those operations mean in the context of a robot. Even if two robots are entirely identical, checking if they are equal returns false because Python lacks the instructions on how to compare them. But after we implement these magic methods, everything changes. Our robot becomes smart and fully integrated into the language. Printing the robot now gives us a friendly, readable message showing its specific model and power level. Calling len now correctly returns the number of tools it carries. And we can even use a standard plus sign to intuitively combine two robots into a new robot team object. By using magic methods, you transform abstract custom data into objects that speak Python's native language naturally. Next, we'll see exactly how this applies to an everyday scenario like an e-commerce shopping cart to write perfectly clean and maintainable code.
Let's recap how magic methods work conceptually before we dive into the code. The fundamental idea is that magic methods transform a raw block of data into a smart object. Because of these hidden methods, your custom object actually understands Python's standard commands seamlessly. In a real-world scenario like an e-commerce platform, magic methods are absolutely vital for writing clean, intuitive code. Let's look at how these methods apply to a shopping cart class. For instance, the string method allows a warehouse worker to print a formatted receipt. The length method tells them how many items are in the cart instantly. The add method allows a customer to merge two cards easily just by using a plus sign. To handle logic, the equals and less than methods let the system compare two cards by their total monetary value. And finally, the contains method allows a quick check to see if a specific item like an iPhone is currently sitting in that cart. This isn't just a theoretical concept, it's exactly how major industry libraries are built. Think about Pandas, a library used by data teams everywhere. When you use a Pandas data frame, you can add them, print them as pretty tables, or check their length. The creators of Pandas defined dozens of these magic methods under the hood so that the library feels entirely intuitive and Pythonic to use. Now let's walk through the implementation of a shopping cart class to see how this is done. We always start with the initialization method to store the customer's name and set up a dictionary for their items. The first magic method we implement is string. When you write print cart in your code, Python runs this method automatically. In our example, it creates a list of strings starting with a header, loops through every item to list the price, and finishes with a total sum. It's designed to be totally human-friendly. The second method is ripper, which stands for representation. Remember, while string is for customers, ripper is for developers. It gets triggered when you are in the Python shell or reading error logs. It returns a technical string showing the exact state of the object, like the customer name and item count, which is invaluable for debugging purposes. Next, we handle measurement and math operations. The length method is simple. Because a length must be an integer, it returns the number of items in the dictionary using the built-in len function on our items dictionary. The add method is triggered by the plus sign. Here, self is the cart on the left side of the plus and other is the cart on the right side. The code creates a brand new shopping cart object with a combined name merging the two items dictionaries into one. By returning this new merged cart, the plus operator works completely naturally for a custom class. Moving on to logical comparisons, the EQ method handles the equals operator. To determine if two cards are equal, we calculate the total price of all items in our current cart and compare it to the total price in the other cart. If the sums match, it returns true. Similarly, LT or less than compares the total values to see which cart is mathematically cheaper. And finally, the contains method is triggered by the in keyword. It just checks if a specific item name exists as a key in our cart's dictionary and returns a boolean true or false. When we test this code with customers Ravi and Priya, the results are clear. Printing the card produces a beautifully formatted receipt. Asking for its length gives us 3. Using the plus sign creates a successfully merged card. And logical comparisons like less than return true because Ravi's total is lower than Priya's. This proves that our custom object now behaves exactly like a built-in Python type. To really master this, consider a few practice scenarios. For a student class, length could return the number of courses, greater than could compare GPAs, and string could print a report card. Also be aware of reverse operations. If you try 5 plus an object, Python looks for radd or reverse add because the standard integer 5 doesn't know how to add your custom object to itself. If you want a final challenge, try building a vector 2D class for a game engine. You would implement addition and subtraction to handle movement and a magnitude method to calculate the vector's length using the Pythagoras theorem, the square root of x squared plus y squared. To anchor all this, here is your final summary of the 7 key methods. String is for human-friendly printing, ripper is for developer debugging, length returns an integer size, add merges objects together, equals handles direct value comparisons, less than determines which is smaller, and contains checks for membership using the in keyword. By defining these standard behaviors, you can now build custom complex objects that are fully integrated into the Python language.